Hi guys, today we want to finish off our amines or amines. Now we have so far covered the reactions of amines. Remember amines, now I'll put it down here right now. Here you have primary amine. Yep, this one is a primary amine. Okay, so well, the first reaction of, I think I would use, because we're going to talk about your ring. So I'm going to use phenylamine, okay? So I better use the pen first. Okay, the blue color. Now remember phenylamine has got this kind of structure. Trying to improve my using of the pen. Okay, and H and H here. Right, whereas you've got your, this one here, your aliphatic amine is just CH2, C and H, and your N, and of course the H here. I will expose a lone pair here, lone pair. So this part here, and this part here, right, have the first thing, of course, the common thing about these two things here is they act as a base. Acts as a base. What's a base? A base is a proton acceptor. They get protonated. Why they act as a base? Because of the lone, they have a lone electron pair here. Yeah? Okay? So if they act as a base, the first thing they do of reaction is the formation of salt formation. Both of them. Okay? They will react with the acid, HCl or whatever, right? To form what? To form a salt. Very important. So this first reaction is common for both of them, see not? Okay. Right? But this fellow here, your phenylamine, have got some extraordinary reactions. Firstly, we will of course is the ring reaction here, right? And it here you can have this thing called the ring reaction with bromine aqueous, Br2 aqueous, where you will get a white PPT, which we did that day, you get your ditribromo phenylamine, which is the white PPT. So two here, instead of the hand. Okay, you get 3 bromine substituted down here. Okay, now this is the ring reaction. Can also go to your dilute nitric acid also. You also get, remember, aqueous, guys. Okay, why? Because the ring is what? The ring here is activated. Again, why activated? It means what? It increased in electron density. Why is it so? Because the lone electron pair of nitrogen what? Overlaps with the pi electron class A. Okay, now the other very important one today we'll talk about is the reaction of this part here, NH2. Reacting to form what I call a Diazonium salt. Form a Diazonium salt. Which will later form a azo dye. Now this is the most important part now. Azo dye. The one that dye all your shirts, all this thing there. Okay? Right? It's very dangerous, so don't play around with it. Sometimes you all throw dyes around. Okay, now we should go and talk about now. Alright, now let's look down here. Okay, remember? Now this thing is called nitrous acid. As you see here, nitrous acid, okay? Nitrous acid. Nitrous acid is a pale blue solution. It's a pale blue. You did before, I told you before that day, pale blue solution, and it's very unstable. You hit the fella, it will decompose. And in a test tube, let's say a test tube here, okay, and this is your nitrous acid here. If you just heat it, warm it, you see here coming out blue, brown fumes, brown. You do in your AS practical fumes or what? Of NO2, okay? It's quite simple. It will decompose to give water, okay? And this one here. So now this fellow here is stable at cold temperature. Means this whole, this fellow here is stable or pretty stable at below. Marking same says below 10 degrees centigrade. So we always say in most books, we put 5 degrees centigrade. That means this experiment must be done in 5 degrees centigrade. So as this nitrous acid here is not very stable, we need to prepare it in situ. It means prepare it there and there, which we done in this here. Sodium nitrite and aqueous HCl, aqueous dilute. And must be cold. Okay, so 1, 2, and 3. These are the reagents. And this is the condition. Okay, 5 degrees Celsius. Okay, right now in exams for this reaction here, you can put sodium nitrite. Now this is sodium nitrite here. 2 here, 2. Because sodium nitrite, ITE. Okay, plus HCl, which is your aqueous, and 5 degrees Celsius. Yeah. So this is acceptable as a reagent and conditions, or you can put HNO2 and 5 degrees centigrade. Okay, this is also acceptable. Let me show you the marking scheme now. Okay, so at least you believe me. See it? You see it? Okay, right. So the fraction here, right, is not here. I put the color first. Okay. Okay, see here, sodium nitrite. Okay, and HCl the black color both must be there. Of course, put equals better, and the condition less than 10. Okay, so 5 is a very common temperature, 5 degrees centigrade. Okay, so all nitrous acid. Okay, by the way, do you know how to get sodium nitrite or not? You've done it in Form 4, hitting on nitrates. But you hit sodium nitrate. This one will not decompose like your group 2. You will hit it, hit the filler, high temperature. It will give you there's no brown films of NO2. It gives you sodium nitrite and plus oxygen. You put 2 here, 2 here, and 2 here. Okay, so this is your substance here. All right. Now this I want to go back now. So marking sequence here. Okay, so what happens? Okay, now this part here, nitrous acid, they don't have any reaction with your aliphatic, but books give you, okay, like this, right? Just to show you how I remember this, okay? Now, watch, okay? See, this is the thing they want. This is called your Diazonium salt. From a covalent substance, right? You get an ionic substance, very important. So here is your, they call it Diazonium salt, okay? The positive is on the nitrogen here, because there are 4 bonds, okay? Whenever nitrogen got 4 covalent bonds, it's very positive because one of them is a dative one, right? So now remember, sometimes they can put like this, C2H5 and 2, positive and Cl, also acceptable. But to put this one here is unacceptable. And triple bond here and positive here, wrong. Salah, cannot. The positive must be on this nitrogen here. Is that clear? So make sure when you do your practice, you make sure you put the positive sign on the nitrogen with the 4 covalent bonds. So how do you get there? Now, what I do is I like to box here. See? So I remember like this, okay? Okay, let's put one CH3, okay? So you learn to draw these things out, practice it at home, okay? Now I'll put the H2 here, okay? Plus, now I expand this on here, okay? right? This is actually like that. O, okay, double bond, and OH. See that? Right? I suppose I will box out the water, see? Plus H, I put the HCl. So this is very useful when you want to remember how to write equations. So what happens is the water comes out. Okay, the water comes out, right? And the N and the N will join together to form a triple bond here. See now? Okay? So it forms a triple bond, see now, here. Right? Two water comes out. All right, and the Cl become minus Cl. Okay, so this is how I remember the whole thing. You try it. Now, this is not important because the aliphatic amine is not asked in exams. It's the aromatic amine. So yeah. Okay. This is the key. You can see after lots of questions on it. Right? How to make methyl orange, how to sunset yellow, whatever. Okay, now how do we do this? Remember, it will always be of a primary amine. You must remember, this to form azo dyes or a diazonium salt here must come from a primary amine. My dear friends, this must be a primary amine, not a secondary. It means it must have two hydrogens here. Okay? So, how do we do it? Very simple. Now, I'm going to draw out what I draw just now. Draw nicely. Okay. Ring, and I don't break up the H2 because it can bond with oxygen. Plus, O, double bond to N, single bond to OH here. And plus the HCl, I put H here and then Cl here. So I box the burger. Box here, water comes out. Water comes out. The N and the N meet together to form the triple bond. See, you see it? See the water. Oh, sorry, here should be two, typo error. Okay, now this is called your diazonium salt. Just, this is the full name, but I can call it diazonium salt. And that's the first chloride being here. See, now this is pretty stable. At 5 degrees here, you can actually crystallize down as a solid. It's quite stable. But high temperature, it will decompose easily. How? Now, this is what is asked. I just go through this out here, then you can actually see that, okay? Then we go to pass the question, okay? Just make it a bit faster. Now, what is the rationale for this thing here? This thing, now this is, okay, now this is, put it up here, that's okay, right? Okay, now this is called a diazonium salt. Remember now, it's called a diazonium salt. Why is it called salt? Because it's got positive cation and negative anion. It's an ionic substance now. Now when you put water and you heat it, must heat you get phenol. That means that the heart, as I said, this fellow here is not stable, right? So N2 comes out and H comes out as a acid. So it doesn't come out as effervescence. Effervescence. Okay, right? You put Ki, you get your iodine, phenol iodide or chlorobenzene here, okay? Right? Copper one. Don't get, but this is the most important one. Okay. The point is how they come up for exams. Okay, now I do this first, okay? Easier, so I don't have to. So you can see how important it is. Right? Now let's get page 113 for past questions. 113. Okay, 113 down here. See, phenylamine can be converted to, now this is your phenylamine, okay? Remember, it's a primary amine, Okay, we're not talking about secondary or tertiary, they should not ask you, but if they ask you, then you better wake up. That means they should not, if it's secondary amine or tertiary amine, they will ask you only for basicity, right? Not for this reaction. Okay, it can be converted to 4-nitrophenol. Okay, it's on here, 4. Why 4? Because phenol, see when they use the last word here, phenol here means the mother. Okay, the root, now this is called, now this is a phenol. Right? Why is it 4? Carbon 1. carbon 2, carbon 3, carbon 4. The pen is very fine, so it's very good. Okay, so for nitrophenol are the following steps. Okay, here you get your phenol. How to change? How can I change from your amine to your phenol? I want to kick out the nitrogen. Then you think of, oh, I must change it to your diazonium salt first. Is it? Yes, not. This is what, see, this is how you remember things, and then you put it all together in this kind of schematic. This is called a schematic diagram, a scheme. We used to say it's a scheme, right? You don't have to balance equation one. You just put the reagents and the conditions, and then what is, the things in between. So if this is the case here, right? How can I form this? That's why I told you just earlier, isn't it? You need to convert it to your diazonium salt, isn't it? So you convert to the diazonium salt first, which is stable at what temperature? At 5 degrees centigrade. So it's 5 degrees centigrade or less than 10, right? What do you use? Nitrous acid equals, or if you don't like this, you can use the complete thing here. What? Sodium nitrite and what? Plus HCl equals, and what? 5 degrees centigrade. You get here your N, right on, but triple bond N, positive here, dot what? Cl minus. This is the thing here. So the reagents here you got here, the conditions here got here, 5 degrees, okay? From here to here, what must you do? Use water. Water, this is water, just water, and you heat. Liquid, and you heat. Warm. Just heat. Okay? Right now. So how to go step 3? Very simple. I want to put the nitrogen up. So remember, this fellow here is activates the rings. Remember, I told you before. So if it's just a benzene ring, you need concentrated HNO3, concentrated HNO4, and 55 or 60%. So here, no need. Just dilute what? HNO3. Now let's look at the marking scheme. Okay, I think this is the one here. This one. No, this one. Yes. Okay, B. Okay, it's a phenol diazonium cation. This one here, right? Yeah, see? See? Okay, B. Okay. We put, of course, Cl, we are more perfect here for that. Okay. Right? B here. Okay, now, step 1, sodium nitrite plus HCl equals all this one here. Conditions, less than 10, 5 the best. 1 mark each. For phenol, step 2, water and heat. Water, heat, or boil. Okay, now, more than 10, heat, boil, anything, both are 1 mark. Okay, the third one here. To go to phenol to nitrophenol here, right? Step 3, obviously, I put here, HNO3 dilute here. Dilute you can put here or here, but here, it's conditions. Is that clear? Okay. Now this is all just on diazonium salt formation of this one here, and some of the reactions. Now we look at for dyes. Okay, I want to go and look at dyes direction to form azo dyes, the one you color your shirt, your t-shirt, your caps, and you use to powder to throw at everybody. That's very dangerous, man, because some of these can decompose into carcinogenic substances. You first don't know how dangerous you get with dye. They die of cancer, then you know. Just be careful what kind of dyes you throw each other. I always warn my students. I can warn you, but I cannot stop you. Say you want to die. Well, nobody's stopping you. But you've got chemistry, you can, protect yourself. Okay, now here's the first part there. From your what? Your diazonium salt. Okay. The next part, of course, is this part here too. It's called a coupling reaction. Okay, where couple means 2 become 1. Like you get married before you get married, you couple then, right? So now this is, of course, what is this? Your diazonium salt, okay? Which came, of course, this came daripada siapa? Came from your aniline, is it? This fella here, this gundu here, right? Right? How to get inside? HNO2, and 5 degrees, or what? Sodium nitrite and HCl equals, and what? 5 degrees. Okay, now this is the other further to a couple. This is actually benzene. Of course, benzene is not very soluble, but somehow you put NaOH here, okay, they will mix quite well. Okay, always with NaOH. Remember, this reaction must be NaOH. Of course, in phenol, you make it a salt which is more soluble. Okay, all this, of course, hydrogen, right? But they want to put one hydrogen there to show that it will react. Okay, when they react here, the HCl comes up. And this part of the bond is going to knock onto here. And the end here with the triple bond here will change to a double bond only. Couple. This is what couple. Now this is when two rings connect to here. What do you call it? They call it the rare zonal structure. Okay, the electron can move up and down. When electron can move up and down, it means the electron can absorb light. You see, so part of the visible spectrum is being absorbed, so you get the color. Okay, and this is called an azo dye. Normally it's red, can be blue, can be whatever. This is called an azo dye. Okay, now you can anything will do. Now this, of course, is the other one, the other couple. This must be coming from your primary amine or your phenol amine. So phenol amine is the first filler. Phenol amine is the first filler you must have to form your what? Your dyes, like here. So this is your phenol. We accentuate the H here because there's H as well. But opposite each other because why? See, nothing to block this further, okay? It's called a steric hindrance. So NaOH will turn this to a salt. So because it's NaOH. Because phenol is acidic, isn't it? So this one here. So remember, this comes out and you force to form this one here. Okay? Very simple, isn't it? Okay, use of dyes, can you see here? Now I'm going to go to one more thing here. You can see all these dyes. In India, a lot of dyes are because they use a lot to make sari, you see. So you can see here, however, these dyes may split off to aromatic amines, and some of them are proven to be carcinogenic. So be careful. Okay. Of course, now the other reaction, of course, is ring reaction we learned before. Okay, right? Now here, now look at this. Okay, we do some first anyway. This is now remember, this is the starting point. Okay, look carefully. Ring. Now, would it be the starting reagent? Ring. Is it our amine? Yes. Primary amine. Now, this is just a substitute group. Don't care. This will give it to be more soluble because it's ionic. So make this shift to make become orange. Okay, so this is the main substance here. So you put sodium nitrite, and this here equals cold. Of course, the cold here means what temperature? What temperature? 5 degrees centigrade better. Okay, they will say exam less than 10. So the range up to you. Okay, of course, when you put this here, you will of course get what? You of course get, I'm going to draw it like this, okay? I'm going to draw the inverse so that you, just to make it easier for you to see. Okay, put here. And triple bond and positive dot Cl minus, and of course opposite here directly, the para position is as, I'm going to write reverse, negative dot and Na plus. Okay, so wait now, okay, and you plus D, so they ask you what is D, okay, and then this followed by HCl and followed by, okay, so what is D to form this substance here? Then you now see the aim from the beginning, okay, right? So I'm going to be smaller lah. Okay, remember these two fellows here, which means to say, right, that this fellow here came from the original first part, yeah, right? Remember the two N. This first N came from the NH2. Yes, not. Yes or not? Yes, this one came from the what? Came from the nitrite, NO2, the sodium nitrite. You know. So these two are here. So this one must be D lah. Yes, not. It must be D. But why do you put con HCl? Interesting thing. Now this fellow here, they confuse you. This is a ring, is it? N, R, and R. So 3 R's there. What kind of substance is this? What is it? Amine. What kind of amine? Tertiary amine. Tertiary amine also got 2 lone electrons here, isn't it? Right? Therefore, it's also a base. Right? That's That's why when you add HCl, right, it will give you, of course, what? H plus and Cl minus. And of course, this one will, of course, sapu this fellow here. To give you what? To give you an CH3 first, CH3 here, and of course, dash to H then. To form this substance. Okay, positive, of course, Cl minus. So now this, why from this one? Because it's making it soluble. Soluble. So ionic soluble and this is also soluble. So mix them together. They will of course right here, right? Right with this one here. Yeah, with your Cl here. Here, remember, we have Cl here. Let's say I put Cl here, minus, and of course your N triple bond and of course this part here. Draw it out yourself. Prove to yourself you know what you're doing. Don't be an idiot. Don't do. Just look at it and say, I know. Cursive especially. Never write it down. Okay, remember the H here? Right? They will bond here and come out. And here will join to your nitrogen here to form this substance. Cannot. Easy, isn't it? Practice it. Now let's look at the first question. All right, which I'll do now for you. Okay. 113, page 113. Okay, 113, here we are. Okay, we seem to have done it. Okay, see the first part here? All right, now this is your primary amine. Sodium nitrite. This one here, you get your what is this? We did just now. Yeah, I forgot. You get your what? You get your azodiazine. Sorry, your this is your diazonium ion. Okay, so diazonium ion or salt. You heat water, you get your this one here. Yes. Okay. So something we've done already. Yeah. Okay. Next one. Question 2. Where's my question 2? 3. Okay, 108. We're all confused. Okay, here we are. Now this is a very nice question because I like all these questions because a lot of you're like a detective, you're going to solve everything. Okay, the following chart shows some reactions of ethyl benzene. Ethyl benzene here, yeah. So if you don't know all this, I would advise you, since you're not very smart, see here, draw it out. Okay, it will help you clearer. The skeletal diagram can be quite tricky, isn't it? Okay, go to here to here. Okay, how to go to bromine here? Very simple, isn't it? Bromination. Go to here to here. What is this free substitution? Yeah, go from here to here. This is what? This is elimination. So for you can do yourself. From here to here, you enter a nitro group. Of course, you use what? You use a con HNO3 and con H2SO4 and 55 degrees or 6 degrees. Here. Okay, nitro NO2 to here. Of course, reduction is it, which you learned before. Tin and what? Tin and concentrated what? HCl. Can heat if you want to, but not necessary. From here to here, now what is this? See now, they put N2H. This is your what? Diazonium salt. See now. So of course, from here to here, what do you use? Same fella here. HNO2 / what is equals a friend and 5 degrees. If you don't like it, you use the whole thing lah. Sodium nitrite. So 2 plus HCl equals and what again? 5 degrees. From here to here, this is your coupling reaction, right? Now remember, you must learn to draw properly. Draw these two near each other. Here, this one here. Okay, I'm going to pick thing here. I'll draw like that. Okay, yeah. Okay, okay, let's draw like that. Learn to draw it. Okay, so I put down here, that means the ring, don't forget the ring. Okay, and 2 is it? You can draw like that if you want to. If you want to be perfect, okay, dot Cl minus, okay, plus. Now you want upside down for here, and you face the NO minus away because why? They will repel each other. And A plus here, okay, put the ring here, and of course draw the hydrogen here. Okay, of course this one will box it out. It's okay the exam I did do this, right? So you get what? You get, of course, the ring here, which is this answer here. Okay. Okay. Of course, if you're in class, that means you can do it in the class. Okay, that's here. Here will be what? And double bond, isn't it? Yes, not. And join to what? To the ring here. And of course, O minus and Na plus. See this ionic stuff, this is ionic, right? Ionic. Make it more soluble. That means the dye is very soluble. Dye is water soluble. Okay? Soluble. Okay? Right? Can see it. X. 10 November 43. Do I have it here or not? Not here. Not here. Maybe not here. It's too simple. 10 November 43. Okay, here. 10 November 43. So, all right. See? Now, they put OH here. See? OH here. OH here. If it's OH here, that means, right, if it's OH here, that means it must be followed by, from here to here, followed by an acid. They should not, because they put any O minus on, okay? So, of course, they can, it's acidic here, okay? Because the O minus here, see now, must be acid. That means OH, any comes out must be acidic, okay? They didn't say it's acid solution, but they should not give it wrong. Where's the full? Okay, see now, see, allow N2 and allow NO and A, see, they allowed it. They allow N2, okay? Remember N2, but not N, triple bond, N and positive here. It's not allowed. We have seen this before in your marking set. Okay, now let's go for other reaction. Okay, we've done this one here. That azo dye, number 3. 340. You need to do a lot of examples here, otherwise you cannot get it. This is a very good question. Before that, okay. Now, just this one here will tell you. This whole question here talks about first your ethyl amine is a base. Okay, it tells you on why is basic, equation of a basic, and also a nucleophile. We done this before already. Okay. Why comparative of basicity with phenol amine? Okay, this is a very good question. It's ask the whole thing on your syllabus. Okay, alkaloids are those bitter herbs. You know, the Chinese, you drink all this bitter stuff. You know, when I was a small boy, I get sick. Always drink. I feel sicker. You drink all those fu cha, all those bitter. My mother would boil all these bitter herbs. Oh yeah, I prefer to take a Panadol. Okay, Panadol is also very bitter if you taste it. Okay, but anyway, you just swallow the whole tablet inside, you have no problem. But when you drink, you know, your tongue will taste all the bitter black color stuff. Anyway, that may be better, of course. Okay, suggest a structure for a product E in the direction of alkaloid nicotine. Now, you smokers out there, this is what you're bringing to your lungs and killing you. And excess of HCl, excess, very important here, excess means a lot, means everything. Okay, now here you look at these two, nicotine here, this and it's C, is it not? C here, see it. Let me see, so what kind is the amine? What kind of amine? It's a tertiary amine. Okay, now guys. That means here they must have a lone electron pair, isn't it? Because nitrogen has got 5 electrons out of the shell, group 5. So 1, 2, 3, 4, and 5. So there's a lone pair here. Why? What happened now? That means it acts as a base, isn't it? It can protonate, it can donate itself to the electron. This one here, This looks like this one actually. It means you need to know all this stuff. Remember the one borazine came out that day? The first thing I thought about amines. Okay, there's carbon, 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 and nitrogen. They can form single bonds, double bond, single bond, double bond, single bond, double bond. Okay, they can form like that. Same. Hydrogen here, hydrogen here, hydrogen here, hydrogen here, hydrogen here. Too bad here no hydrogen. They got low electron pair. Okay, if from a hydrogen bond, if there's a hydrogen bond, it'll be positive sign there because there are 4 bonds here. Do you understand? See what I'm saying is, if they do this and triple bond here, okay, this must be positive because there are 4 bonds. 1, 2, 3, 4. Why? 1, 2, 3, 4, 5, isn't it? So because there's no positives here, that means there's a lone pair here. Okay? So lone pair is new to you. Yes, new to you. So nitrogen, lone pair. That means it can also be protonated, is it? H plus here, because what is an excess. So what happens then? This fellow here bond to here, so bond to here. See? Excess HCl. So you must open your eyes. Don't be an idiot. So what is the structure? You draw the whole damn thing. You repeat the whole structure here. You don't care. Nitrogen here, okay, down here, and of course you put the thing here. Draw the ring, don't care, and here, okay now, right? So put a H here and put positive sign here. Okay, don't be an idiot. Here, CH3, and what? H here, and put a positive sign here. Nothing wrong, one. Right? 4 bonds in. Okay, right? Now let's look at the marking scheme. I think I got it here. It's 12 November 42. Okay, bingo. See now, see? Positive, see now, minus. Positive, see now. Okay. Do you see that? My dear friends, okay, H here. So the excess H here is to show that both of this nitrogen here have a lone pairs that can protonate. Okay, huh? All right. It's a good question. The next, of course, is our question now. Phenylamine and substituted phenylamides are used to make cloth dyes and food colorants. All your Maggi mee, all colors, all your strawberry jam, all the colors, all come from this. Make sure that they are approved dyes. One year I've got a long time ago, no Smarties. Smarties are the one that, you know, all the colored chocolates in. 1 year they have to withdraw all the samples because the blue color was found to be carcinogenic. And they were killing all the babies, all the little children. Oh, I want Smarties, I want the blue color. I want the blue color. Blue. Die of being a blue idiot. They actually withdrew it. I read, maybe it's true, fake news, I don't know. But so you want to give your brother, your sister, and you yourself, please, you buy chocolate, just say normal chocolate. Don't put colored chocolates, okay? Don't be an idiot. Okay, the first step is to produce the Diazonium salt. The positive sign is right there. Yeah. State the conditions very simple. What is this? So if you have a tablet like me, you can write here. So simple. Okay, H what? HNO 2 equals what temperature? 5 degrees centigrade. Or you like what? Sodium nitrate. I keep on repeating this, my friends. Because I know how idiotic you fellas are, how slow and how little brain power you have to retain. Keep on writing. When you write something, your brain will register one. Okay, this is the one here. You can see the answer here. I forgot which one is it. No, yeah. So I also forget. Yeah. Yes. Okay, see here. All right. HNO2. You put it on here, you are bloody fool. Negates, it means again 0. It's nitrate, it's not nitrite. Okay, now here, this part here, this is a fantastic. This is to form your azo dyes. Look carefully, open your big fat gundu eyes. The Diazonium salt is reacted with phenol or any aryl. The thing amines that don't want to trick you. Amines, so what? See? It means there's another amine coming out. In alkali, always in alkali solution. Okay, now here, So when this, remember this fellow here, this guy here, came from what? Came from your primary amine, your primary phenol amine. Remember not this one here, you must always remember your roots. And H2, from here to here. This must be there. The other fellows here, you can, this fellow here, whatever, this fellow will not make the dye. This fellow must be there first. Okay? To form some, of course, it's your H and O2, 5, okay? So here. So now if you regulate this one here, of course, now this fellow here will give what? Will give you your N minus Na plus, okay? Because why? Because your OH here is acidic, isn't it? Yeah? Okay. So remember, it will bond. Yes, not. So actually, what happens is that if I want to put here Na positive dot O just to save space. Okay. Okay. Right? Sorry. Yeah, reverse it. Full reverse it. Stupid son of a. Okay, it cannot work. Yes. Okay. Go back to here. Okay, wait now, okay. Now, I'm going to put, it's a hydrogen. Now, remember there's a Cl minus here. Remember the hydrogen at the other end, okay, H here. You must remember where is it. Keep on drawing, draw until you're very used to it. Your O minus is here, okay, right? And your Na plus is here. Okay, so this one will come out. This one here. Actually, it is Na minus and Na and here. To get this one here, I must add what? I must add acid. Acid HCl to get this one here. Because Na plus will come out when the acid is there. Okay. So never mind. That's why chemists sometimes they change the goalpost every time something put you wrong. So here, same thing. Right now, here will be what? I'm going to put here. Okay, that means now remember this fellow here. This fellow here. This your what is this? Tertiary, isn't it? Tertiary amine. But it will be the hydrogen at this end here that will react on. Yeah. Okay. So you shift the whole thing around the same, isn't it? Yeah. Okay. That means here if you have got the H here, okay, I'm going to draw it a different color now so that this is better. Okay. All right. You put the N and R2 here. Okay. So the Cl from here to here. So N go to here. Okay. You get this one here. Okay. So that's how they give it an example. This is an example now. Okay. Now, so here they ask you here. Starting materials. Suggest the starting materials you needed to synthesize the following dyes. Draw the structures in the box below. Now look carefully. Now this is a alizarin yellow dye here. Yeah. Okay. Now look. Use the brain a bit, please. I'm going to make it smaller. Not your brain. I'm going to get this over here. Okay. You see, you must compare here. This is your alcohol, okay? Right? This is your amine. So in this case here, there's an alcohol here, okay? Right? It means this part here. It means this whole part here. This whole must be the second substance. That means this part here must come from your what? Must come from your azo diazine, also your diazonium salt, isn't it? Yes, must come from this one here. See? So this is the first part here, which means this must be, then draw the further first, draw the ring here. So you must look at the example they give you. Don't draw reverse, don't draw this for this. Don't, okay? So here, NO2, here will be what? Your and a positive here. Cl minus here. Yeah. And the other part will be, just draw that. It's your second one. Okay? Anyway will do. Okay, put the OH here. And your CO2H here. Because it is this hydrogen here that will react with the cells in it. Cannot. Okay, now next one here, before I look at the answer, okay? Here, again, look at this whole picture, metal orange. Now remember, so which part here is the which part here is a primary amine or your phenylamine? Look again. The example they give you here is a tertiary amine now, and R2 is it. Now which part here got tertiary amine? This part now, yeah. So this part here, this further here must come from the second substance, and this part here must come from your where? Come from your what? Diazonium salt. See now, you use your brain. It's a big molecule, so they think people here are quite stupid, is it? So you must give it some chance. Okay, so here of course it'll be what? We use red. Going to be time already. Okay, so here be draw the further first, draw the ring first. Okay. Okay, here draw your SO3 and A, positive, negative. Okay, here will be your what? I know the bloody ends. Here will be your N triple bond, and you can put N2 is okay, huh? Positive here and your Cl minus here. Here, of course, you can draw the structure here like that. Okay, and of course, you can put CH3 here, up to you. Okay, that's all. Yep. Okay, now let's finish all this one first, okay, because time is catching up here. So just why the effect of this sodium sulfide group in metal orange has on its properties. This guy has no effect on color. It makes it more soluble because ionic, that's what make it more soluble. Now let's look at the answer, okay? This one. This 12 November 43. No? Okay. Yeah, see now. Alright, see, alright, now this one here. Remember? Right, see here. Nitrogen. Nitrogen, okay? I put triple bond now. Now see the markings here. Okay, now. Right? See, you can put like this, right? It's also the accept now. Fantastic. This see here they don't want N2 positive, is it? Interesting, is it? Other time they're gonna put N2. Okay, so this is not, but not, so be careful. Okay, be careful. In exams, they can change the goalpost. This is the best deal, because this is the actual one. And triple bond, and the positive must be on the nitrogen with the 4 bonds. Is that clear? Gundus, all of you, make sure you know the answers. You are smart. You can get the right answer. You should get the A star, but you go and, I don't know what goes in your brain, okay? Okay, that one, of course, is one here quite simple, okay? Okay, right? So metal orange again, see on this one here, okay? Okay, all right, can okay, so here, see, here, you can put NH2, and actually this one, they start from the original. So here, they suggest the material use, that means they want the original, sorry, okay, original. I thought here they want this one here, but can also, they say either way, so wasn't it? Okay, so now this is the very common. Now why is it, I didn't tell you, make it more soluble. Why is it? No. See now, makes a molecule more hydrophilic, love soluble in water, so hydrogen bonds, ionic solution. Okay, increase the melting point. Okay, so this is the reason for this one here. Now, time is catching up. I will give you the other questions later. Okay, but this one I thought was very good, and it's the most difficult question of all. Okay, I want 10 more minutes with you. This is the most difficult question of all. Okay, page. You can try and do it yourself again. Even after explaining, I think you still cannot do it. Right? This is my idea. Anyway, I could be wrong, as I said. I'm not very good. We'll be telling people what they're good in and so forth. Okay, page 389. I hope I'm correct on me. 389. I took some time to do it. Okay, so then this is the famous question, right? Let's read carefully. I want to make it bigger. Nitrobenzene. okay, this one here, can be reduced to phenol, okay, which we did before, isn't it, right? How to produce here, okay? What do you use? Tin and what? From here to here, we use tin and what? Concentrated what? HCl, isn't it? Okay, now this is the thing they are testing you. In acidic solution, is a two-step process. Balance half equation for this reaction to work out how many moles of electrons are needed to reduce 1 mole of nitrobenzene, blah, blah, blah. So talk about electrons. How to do it? Ayyo. Very simple. Look, if you don't know the electron, the oxidation states are very simple. Remember, in all reactions, in all reactions here, right? This is neutral. So the only thing is your hydrogen must be neutral, must be H. Okay, if H plus, it means if here there's no ion, there's no positive ion. It means this H must be neutral, must be H0. So how to make H0 is 1 hydrogen positive here must take 1 electron. Okay, that means here if you react, it must be 1 electron balancing 1 hydrogen H plus. So now is to balance it first. Remember, it forms this H2, that means 1 H here. If oxygen comes at 2, so I must put 2 here. That's not 2 oxygen. Is that clear? So how many total? How many hydrogen there? 2, 4 plus 2, 6. Yep. So 6 here. Here must be 6. This simple. Of course, after I tell you it's simple. Okay. Now the first part is done. Okay. The second part here. The reducing agent normally uses granulated tin, right? And corn, same as corn. I tell you, sometimes in market they put dilute, it's not good. Okay, concentrate hydrochloric acid in the first step. The reduction of nitrobenzene to phenol and ammonium chloride can be represented by the equation blah blah blah. Use oxygen states in electron transfer and balance equation you might find useful. Okay, now remember, look at it carefully. This whole thing here, you can use one here. Now remember, this is the first equation. I think I put the other equation here. Yeah, right. Now the other equation, of course, is for what? Is for tin. Must put slowly, otherwise. Okay, plus HCl concentrated. We give you what? Okay, remember here, plus here. Okay, now these two are in the second equation. Okay, this one here later. Okay, to give you what? Now these are the products they give you. Okay, and plus of course here. All right. Tin, okay, tin from your SN. Now it's not Cl2, it's NCl4. And plus, of course, you balance it with H plus N. Yeah. Remember, this is charge 0. This is plus 4. This is how you do it. That means that from here to here, tin is acting as a reducing agent. It's a supplier, a donor of electrons. That means here, from here to here, it must lose how many electrons? Must lose 4 electrons. Plus here. Or I put minus here. Right now. So in the hydrogen here, there are 4 here. 4 here, so must be 4 here. Chlorine here must be 4, so 4 here. 4 here, it must be 4 here. Yes, not. Yeah. So now this perfectly balanced. Got it? So far? Now then you add these two together. Remember, this is a redox reaction, is it? Okay. 1 and then 2. Okay, now to make 4, here you need 1 more need 6 electrons. 1 more get 4 electrons. No, how to make these two same? Same, okay. So I need to times this by 3. I need to times this by 2. So I'm going to put it down here, guys. So I put down here. Where's the full? Okay, put different color now, so more exciting. Blue. Okay, the top one, okay. I'll put down first, okay. C6H5. Very exciting, isn't it? And 2 times by 2, so it's 2 here. Yep. Plus times 2 is 12 electrons. Times 2, 12 H plus. Goes to times 2, 2C6H5. And H2 times 2, 4H2O. Yep, this is your equation 1. Okay. Equation 2 times 3. So get 3Sn plus times 3, 12 HCl. Don't be afraid of the numbers, my friends. Times 3, 3, right? SnCl4 times 3, 12 H plus times 3, 12 electrons is equal to. Okay, now I'm going to shift down here, okay? So don't need the top there anymore. Okay, now look carefully. I now want to balance off the equations. Okay, right. Okay, now they tell you here what is formed is not this one here. They tell you is N, which means that this further here will have one more reaction, is it, my friends? So this one here. Now later we do the one 2 by 2. Okay. Now we cancel off the electrons first. Okay. So you must look. I put another color lah, so you are more excited to see different colors. This is the equation. But we have here is this further here. So how to get from here to here? Okay, never mind. Let's go back to blue. Okay, exciting, is it? Okay, cancel off. All right, H plus 0 can cancel. Electrons 12 can cancel. Okay, so what remains is 2 C6H5. Take some time, you know, there's 2 marks here, 2 stupid marks. You want to do it. You know, 2 plus 13 plus how many? 12 HCl. Okay, done. Okay, all done, huh? Give you what? Give you here 2 C6H5 and H2 plus 3 SnCl4 plus 4 H2O. But then this fellow here, all right, 2 C6H5 and H2 must have a HCl, no? Yeah, why? Because the base, full base, right? To give you, of course, 1 so 2 have 2, isn't it? All right, you give you 2 C6H5 and H what? 3, and here positive and Cl minus to be perfect. Here not perfect, huh? Okay, here they should have a positive and negative here. Okay, then it's perfect. But never mind. Cambridge what? You don't argue. Okay, 3. Why not? SnCl4 plus 4H2O. So the final total equation, my friends, my dear beloved students, I'm going to do down here. So this one can cancel, yeah. So I get what? 2 C6, a lot of time, huh? I tell you, no joke, man. For 2 marks, not worth it. But what to do? You got a lot of time, is it? You can get A star, is it? Huh? Here, me, 12 plus 2, 14. HCl. Beautiful, beautiful, beautiful. 2 C6H5 and H3. Don't want the positive one, follow them. 4 Cl plus 3 SnCl4 plus what? Plus what? Plus the water, isn't it? Yep. Okay. Sorry, I should not include this one here. Why I'm so dumb? I should include something. How come? Okay, right. Sorry about this. Okay. Apologies, man. Apologies. Mr. Simon is also smart. Quite stupid one. You know, I'm quite stupid. I'm just very clever. That's 4H2O. Okay, now. So this is the answer. Got it? Now let's look at our answer. Okay. I think somewhere here. Where the Gundu answer? Okay, here. The first one, 6 electrons. Okay. Okay, 6 electrons and 6 plus 1. What is this Gundu? Okay. See now. Okay, why have we got 6 electrons? 6 electrons. 6 electrons. Yeah, and 2 water. 2 water. What am I doing? Okay, last 5. Okay. Second one. 2, 14, 3. 2, 14, 3. 2, 14, 3. Voila! As I told you, I'm quite clever. I'm quite stupid only, but I'm quite clever. Okay now. So learn to do it. Repeat, repeat, repeat. Now you can do the rest of this question here by yourself. Okay, except it's only a partition only, okay? But this math you can calculate out. So you can see it comes out in a variety of methods. Even in this stupid equation they will ask you. Which means, hey, nothing is bad as long as in the syllabus, they can ask you, baby. Okay, now let's go back quickly. I just want to finish off. I don't think I can finish off everything, but so far we are done. We're almost done, okay? Page 92. Okay, a bit smaller, right? You can see here, I've done all these dyes already. Finish all this. Okay, now all this finished already. Right now, just on this comparison part here, I will do next day. Okay, or just one last part. Remember I told you about the FeCl3 with phenol. Remember not? Okay. Go back to again. Okay, page 82. 82. Sure, 82. This 96. Okay, 96, 82. Am I finishing? Yeah, not this one. 64. I told you before this special reaction. Okay, for phenol, okay, for phenol here, right? Phenol here, okay. Special reaction with iron 3 chloride here, iron 3 chloride here, right? You get a purple color, okay, right? Because phenol is colorless. So now in your phenol and aniline or phenylamine here, special reaction 98, 89, 98. 98. Here. See now, again, purple color also, okay? The phenylamine, but this one is a bleaching powder, bleaching solution. This is the one they use to the Clorox, okay? You put sodium hypochlorite here, you get purple color. Same, the color is the same now. Okay? This is your phenylamine. Okay? Use bleaching solution. But if you have your phenol, also get purple color, but use a FeCl3 alkaline. Okay now. Just to let you see a bit difference. The rest of them I would just go through again. Just let you know that there's such a thing called one reagent to give you a purple color. What are purple colors? Okay. Right? Now I finished already. Alright? I just want to go through a bit more of this kind of thing when we meet tomorrow, whatever. Okay? Also want to start this part here. Okay? I don't think I need to go through time already. Okay, so I will go, the next time, of course, I'll finish off the amines and I'll start with amines. Really, amines can finish off, no problem. Next one. Then I'm going to finish off your amino acids. Then we are done, We are almost done in acyl chloride. Next week, I'll do the whole thing. I'll promise it. Then I'm done. So 3 more weeks, I'll organize. If you have done, if you don't done, then forget it. I'll organize a Zoom session. If you want, you let me know. Okay? That will be on the first week of August. Right? Which is, I think, next week, is it? Let's check here. First week of August. Okay. That's right. Next week, first week of August. Okay? Here. So you can let me know. Okay? If you don't know this from you, you don't want to, I rest. I don't have to Zoom you. Okay? I'm not being paid for it. I'm doing it because I love Jesus. Okay. Okay, I want to end here. So, Wiedersehen, goodbye, and please study hard, okay? Otherwise, you will, I don't know.